All right, so this is 9.05 for geometry. It's on dilations. You are going to need a compass, so you want to grab that and a straight edge. And we are going to get started. This is a video that I already did, and the microphone wasn't working, so it's very frustrated. So we're going to do it again. So grab your compass, and take a look at number 1. And I apologize, it's a little blurry here, but I'll attach this assignment onto the on Google Classroom. All right, so describe the dilation of segment RS after a dilation of scale factor 2 in the center 0, or O. Show the locations of the images of point R and S. So since we want to dilate it by 2, we need to first realize that O is our center right here. And we want to make S so that it is twice the distance from the center. So you don't want to go to the left, because then it would be the same distance from O, just on the other side. So that's when we talk about negative dilations. But here, we're going to take your point and put it on the center, and then mark off where point S is. And you want to make sure you leave that mark on there. And mine is a little bit off, so I'm going to fix that. These points are really big, so there is going to be some error there. So point O is there. And make sure you leave that mark on S, because that's how you show your work. And then you're going to take your compass and put your point on S now and mark that off, that same distance off again. And that's going to become your S prime. So now I've doubled the distance from the center to find S prime. Now pause your video and do the same thing for R. All right, so I put my point on O again, mark off R, put my point on R, and mark off that same distance. And that will become my R prime. So if you did take a ruler to actually measure as opposed to a straight edge, here you can measure the distance between R and S is about 5 centimeters. And then the distance between R prime and S prime should be about 10 centimeters. It's slightly off because of those points. So for this one, I want you to really focus on this picture, because we're going to come back to that throughout the lesson. And this is if your center of dilation is on the line. Remember, a dilation means that you are either getting bigger or smaller. It's the only transformation that we have that is not a rigid motion, so it doesn't preserve the distance. The size of your shape would change, and in this case, our line. So for the next one, the difference here is that instead of our center being on the line, our center is not on the line. So what do we do here? Well, here's our center O, and here's the line that we want to dilate, which is EF. So we want to dilate this one by a scale factor of 1/2 with a center at O. So to do that, again, we look at each point individually first. So we're going to look at E, and we want to make the distance between OE, we want to find half that distance. So when you talk about a dilation of 1/2, we're getting smaller or closer to your center. And as you get further away, you're getting bigger. So the first one was a scale factor of 2, we got bigger, double the length. Scale factor of 1/2, we're getting smaller. So to do that, you want to first connect, using your straight edge, connect point E to your center of O. And then you're going to use your bisector construction, so the one that's like a fish. You're going to extend more than halfway, and you can do the full half circle, or you can just mark off the 2 intersection points. Use your straight edge to connect those 2 points, 2 intersections, and this will become your E prime. Pause your video and do the same thing for F. All right, so you're going to connect the center to point F, and then we want to bisect that using our compass. So you're going to extend more than halfway and mark off above and below, keeping the same setting, put it on F and mark off above and below. If you didn't have enough, you could always go back and extend a little further. taking your straight edge, line up those two intersections. And this point right here will become our F prime now. So now I can take, and I'm going to use a different color here, connect my E prime and F prime points, and then I will have my new line E prime, F prime. So notice that your given line and this new line are going to be parallel to each other. And this one, the new line, is going to be closer to your center of O. So the distance, you're taking half, the new line will be half the distance from your center, which is O. And also here, your given line and the new line, so its image, should always be parallel. And that's really important. So that's what we're talking about right here. The dilation of a line passing through the center of dilation. So that's like number one, the line is passing through the center of dilation. That's going to be the same line. So in here, our RS and R prime S prime are the same line. They're all on that same line. Where on number two, when the dilation is not passing through the center of dilation, then you're going to end up with a parallel line. So here, point O is not on the given line that you're dilating, so your new line will be parallel to that. All right, for number 5, write the equation of the line y equals negative 2/3 x minus 5 after it has been dilated by a scale factor of 4 about the origin. So with the origin, it's a little bit easier than if it's not at the origin. So if your center is 0, 0, so your origin, here's what we're going to do. First, and this is going to be the first step, whether it's the origin or not, is you're going to test to see if the center of dilation is on the line. And we'll talk about a couple different ways to do that as we do some more practice problems. If the answer is yes, then you're going to have the same equation because it's the same line. If your answer is no, that the center is not on the line, then you're going to multiply the y-intercept by your scale factor. And we know they're parallel, so they'd still have the same slope. So that won't change. All right, so first let's test to see if 0, 0, the origin, is on this line. So 0, 0 is xy. So we're going to put in a 0 in for y, and we're going to put in a 0 in for x. So now I have 0, negative 2/3 times 0 is 0. 0 minus 5 is negative 5. That's not true, which means the center is not on the line. So if that's the case, then we're going to take our y-intercept, in this case negative 5, and multiply it by our scale factor of 4. So our slope stays the same, negative 2/3 x, negative 5 times 4 would give us negative 20 for our final answer. If we ended up with a true statement like 0 equals 0, then our answer would have just been y equals negative 2/3 x minus 5. It would stay the same exact equation. So what's really important here is testing to see, is the center of dilation on the line? So then like number 1, it stays the same line, or if it's off the line, in that case, it becomes a parallel line. And then you need to find the equation of that parallel line. So that one's always going to be the one that's a little harder. Now you also can do a test here by putting y equals negative 2/3 x minus 5 in your calculator, and then checking the table for the point 0, 0. So just going to your calculator and typing in negative 2/3 x minus 5, go to your table, and then we want to go to 0, 0 this way. And at 0, we're at -5, like we found here. So it's not, the 0, 0 is not in the table, which means it's not a point on that line. So the center of dilation is not on the line, so we end up with a parallel line. All right, number 6. Write the equation of the line 2x minus 2y equals 12 after it has been dilated by a scale factor of 2 about the point 1, 2. All right, so these are going to be a little bit more challenging because our center is not at 0, 0. Our center is at 1, 2. So the first thing you're going to do is the same. You're going to check to see if the center is on the line. So you have two ways of doing that. One is to take this and sub in your x and your y and see if it ends up with a true statement. So 2 times x, which is 1, minus 2 times your y, which is 2, equals 12. And put a little question mark over there. So that's 2 minus 4. Does that equal 12? And negative 2 does not equal 12. Therefore, it's not on the line. Or you can put it in your calc, which means you do need to get it into y equals mx plus b form and check the table for the point 1, 2. So to do that way, we would subtract over your 2x, divide everything by -2, leaving us with x minus 6. So then we would go to our calculator, type in x minus 6, go to your table, check at 0, 0, and the point's at 0, -6. So that tells us it's not on the line. So what we know now is that the center of dilation is not on our line, which means it's going to be a parallel line as opposed to the same equation. So we need to find the equation for that parallel line. So what we're going to do is choose 2 points on your given line. And then we're going to dilate them by 2 about the center of 1, 2. So to find those 2 points, you can either just choose a value for x. So we tend to choose like 0 and 1, things that will be easy to find, and you can substitute them in. You could even put them into this slope-intercept form. So putting in 0, you would have 0 minus 6. If I put in a 0 in for x, 0 minus 6 is -6. If I put in a 1, 1 minus 6 is -5. Or we already have this in our calculator. We could go here and grab some points. So 0, -6, 1, -5. You could take 2, -4, whichever ones you want. Obviously, you want to try and choose some lower numbers to do this. So now we've got to dilate those about the point 1, 2. So I'm going to go over to my graph and plot the point 1, 2. I'm going to call that C for my center of dilation. Now I'm going to graph the point 0, -6. So 1, 2, 3, 4, 5, 6. Now let's call this A. We'll call this one A and this one B to keep it straight on our graph. Now to dilate a point, we know, and based off of our constructions we just did, we want to go, if we're doing a scale factor of 2, we want to go double the distance from point C. So first we need to see how close we are right now. So I'm going to count from C to A, so how much I'm going down and over. So that's 1, 2, 3, 4, 5, 6, 7, 8. So down 8, and then to the left 1. So now I'm going to repeat that. 1, 2, 3, 4, 5, 6, 7, 8, and then left 1. So that becomes my new A prime. All 3 of these points should be on the same line. I should be able to take a ruler and draw a line through all 3 of them. And A should now be double the distance. A prime should be double the distance from C as A was. So now A prime has coordinates -1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that becomes -1, -14. Now let's do the same thing for B. So let's take B is the point 1, -5, 1, 2, 3, 4, 5. And that goes straight down from C. So we're counting 1, 2, 3, 4, 5, 6, 7. So I'm going to go down 7 in that same vertical line. 1, 2, 3, 4, 5, 6, 7. And that becomes my B prime. So now the new coordinates for that are right 1 and then down 12. So now I have these 2 points, A prime and B prime. So those you should see right from your graph right here. If you were to connect A and B, that original line right there should be parallel to our A prime, B prime line right here. So, and this line is going to be twice the distance from C. But again, when you're dilating each separate point, just like we did on the front when we did our constructions here, you're connecting the center and the point, and then the new point, the image, should be on that same line. Same thing here. The image and its pre-image are both on the same line as the center. Okay, so now we have our 2 points, but we were asked to write the equation of that line. So now for step 3, we're going to write, I don't have much room here, but write the equation using the 2 new points, and that's really important to use those 2 new ones. All right, so in order to write the equation of a line, y minus y1 equals m times the quantity x minus x sub 1, I'm going to substitute in. I need a point and I need a slope. So a point, I have 2 of them, I can just choose, but I need also a slope, which our formula is change in y over change in x. Okay, so now I'm going to find the slope of these 2 new points, our A prime and B prime. So I'm taking negative 12 minus negative 14, so plus 14 over 1 minus negative 1. So that gives me 2 over 2, which is 1. So now I'm going to choose one of my points. I'm just going to choose A prime and substitute in. So 1 plus 14 equals my slope, which is 1, x plus 1. So I'm calling this my x sub 1, y sub 1 point right there, the green one. And let's put it into slope-intercept form. So here, if I distribute 1 into here, it stays the same. And then if I subtract my 14 over, I would get x minus 13. So the equation of this line right here should be y equals x minus 13. And it looks like it hits right at negative 13 right here for the y-intercept. So that looks like it checks out graphically as well. So a lot of work to figure this out. So first thing that you're going to do no matter what is first check to see if your center of dilation is on this line. If it's on the line, it's the same line and you're done. That's your answer, 2x minus 12, 2y equals 12. If it's not on the line, which this was the case, it was not on the line, we know we're going to end up with a parallel line. So it is going to have a slope of 1, but a different y-intercept. So what we do is we choose 2 points that are on the line, any 2 points we want. You can use your calculator to find them, or you can just substitute in 0 and 1 and find your y values from there. I'm going to try to avoid fractions, of course. And then you're going to dilate them by 2. So we graph them, and then you're going to count over and extend it that same amount. So it's that double the distance from your center of dilation, and then write an equation of the line using those 2 new points. All right, for number 7, same idea here. Write the equation of the line after it's been dilated by a scale factor of 3 about the point 37. So our first step is going to be to check if the center is on the line. So again, you can do this using substitution with x and y, or in your calculator, or a good idea is to check it in your calculator so you can do both. Pause your video, do that right now. All right, so you should have had 5 times 3 minus 2 times 7 equals 1 with a question mark. So that's 15 minus 14 equals 1, and 1 equals 1. That's true, which means your center is on the line. Therefore, it's going to be the same line. This is like number 1. So I want you to keep going back to these 1 and 2 from the first page. So if the center is on the line, it's the same line. So use the same equation. If it's off the line, you get a parallel line. That one's harder to do. So here, it's the same line. So our equation is just 5x minus 2y equals 1. I took it right from the original. Okay, again, you also could put this in the calculator and check the table. So it'd be a good idea here to check and do that as well. And you can always graph it out if you need to. And that's there if you do need to dilate any of your points. It's always good to do that on graph paper as well. All right, now we're going to move on to a couple more constructions. So related to dilations. For number 8, you're going to construct the image of triangle RST after a dilation centered at C with a scale factor of 2. So your directions for this are at the bottom. And we're going to start by doing point R. And I want you guys to remember and keep in mind here, if you are dilating by a number that's not a fraction, so bigger than 1, then you're going to get bigger, which means you should get further from your center. So you're going to double the distance from the center. So let's start by connecting C and R. So it says to make CR. And you want to be careful too. Some students try to go to the left, and you don't want to go to the left because then you're not making it double in that same direction. So now we take our compass, and we're going to, when it says measure CR right here on step 2, it just means using your compass. So mark that off, and you should leave that mark to show that you measured it with your compass like I just marked, and then put your point there and mark off that same distance again. And now that is my new R prime. Now you're going to do the same thing for S and T. Pause your video and do that right now. All right, so I'll do T next. And this one, I know I'm going to make it double the length, so I need to make it a little longer here. Use my compass, put my point at C and the pencil at T. Mark that off. Make sure you show that mark. Then put your point at T and mark that off again. Same distance. So now that's T prime. And then lastly, we're going to do it for C and S. And you want to make sure you double that. And use your compass. Put your point on the center. Mark off S. And then again, show that mark to show your work. Put your point on S and mark off that same distance. And this becomes our S prime. And then your last step is to connect all 3 of your points. So S prime, R prime, and T prime to make your triangle, which should look similar to the original. They should have the congruent angles and their sides should be proportional. So S prime, R prime should be double the length of segment SR. As you can see, like inside these lines, as you get further from the center, your triangle is going to get bigger and bigger. As you get closer to the center, it's going to be smaller and smaller within those. It's always going to be within these lines that it will happen. All right, so now let's try one with a scale factor of 1/2. And these can get a little bit messy as well. So just sometimes it helps to use colors and keep it nice and neat. So construct the dilation centered at C again with a scale factor of 1/2. So for this one, we should be getting closer to your center. So let's start with M. So here's point M, connect it to your center first, and then we want it to be half that, since we're at a scale factor of 1/2. If it were a quarter, then you would want to do 1/2 twice. So you'd find the midpoint first and then take half of that. So now I'm going to do this. To keep it neat, sometimes I only do the arcs above and below. Put it on M, mark that off. Sometimes it helps too to make that color coded even. So like these two, we'll make green for point M. Use your straight edge to connect them. So this point right here, that's going to be M prime. So if it had been a scale factor of 1/4, then I would now take half of my half and take half of CM prime to get a quarter, to do a scale factor of 1/4. So that would be even closer to the center. Okay, and now pause your video and do the rest of them on here. All right, so here we're going to connect A to C. And again, we're doing a scale factor of 1/2. So I'm going to extend more than halfway, mark that off, above and below, keeping that same setting, put it on the center of C now. See, mine didn't quite reach. So I go back and just extend that a little bit, make that really clear. Make that with pink. As you'll see how sometimes they can get a little bit confusing. So now connect your two pinks, and that point right here will become my A prime. All right, and now I'm going to do H. So connect that to your center, and then bisect that one. So extend more than halfway, and then mark that off. This one is where it gets a little tight. It's close to the others. And H. And I'm going to make that one my purple one. So now using my straight edge, connect those. It's right here. So that's going to be my H prime. And then lastly, our T. So we're going to take T, connect T. Sorry about all the banging and garbage can rolling. And then we're going to bisect that one. So here we're going to go more than halfway again. And swing down. See, it gets a little messy down there with all the different arcs. So here, do this black. Sometimes you got to mark it as you do it so you don't forget which mark you should be looking at. So here. And then we'll connect those. Would be our T prime. And now you just want to take your straight edge and connect all 4 points. And again, you're creating similar figures. So they should be, the sides should be proportional, and all of the angles should be congruent. So you can see here that this one, and sometimes it helps to see it in a different color to make it pop a little bit. So if I make this one pink, this one, again, it's always inside these lines of the outside lines. And this one's smaller and it's closer to that center. It should be halfway between the original and that center. All right, and then lastly, this one's a little bit easier and faster. Using constructions, find the center of dilation shown below, which has a scale factor of 2, and label the center C. So there's a couple different ways of doing this. Usually the fastest way is just to take your straight edge and connect your corresponding points. So you're going to connect D prime and D, and you're just going to extend it a ways. Now you're going to do the same thing for E prime and E. So connect those two and extend. And that's actually going to show you where your center is. I always like to do the last one just to verify. It's fun to see them all line up. So we're going to take F prime F, and you see all 3 of those lines should intersect right here, and that would be your center of dilation. So again, you're just going to connect your vertices, and those should be your corresponding vertices. It's important they're corresponding. And then extend those lines until they meet. and that will give you your center of dilation. Now, if you want to verify that, or another way of doing it is to use your compass. And if it's a scale factor of 2, like it said here, you should be double the distance. So you can mark that off using your compass, and that should work for all of the corresponding vertices. They should be double the length to get to the center. And that is it for your dilations today. So again, really, really important that you focus and kind of put these images in your head. So number 1, if your center of dilation is on the line, then if the center is on the line, then it stays the same line. It's the same equation. If your center of dilation is not on the line, so given this line and this center of dilation, your new line would be a parallel line. And that's really, really important to remember for all of those equations that we do. And you can see it through the constructions as well. All right. I hope you guys have a great day. And I hope to see you all soon. And pie out.